Hello children, how are you all? Hope you all are doing well. Welcome to Electron Chemistry Center. This is VKM and welcome to Alcohols, Phenols and Ether session. Children, as you know, we had finished Alcohols, Phenols, Ethers theory part. Yes or no children? APE, Alcohols, Phenols and Ethers theory part is done. Now we are going to discuss about solving part. Solving part we are going to discuss it in today's session, and that too as a separate headings. First I will talk about alcohols, then followed by phenols and then ethers. Right, in an order I'll be discussing the questions based on alcohols, phenols and ethers. I'll try to cover most of the important questions which are required for your competitive examinations, NEET, JEE or for CET. Understood? So without delaying it, I'll be going to the discussion of the questions. All these questions are from level 2 questions. As level 1 you can solve it easily, that's why I'm discussing level 2 questions. Okay? Let's say this. 2,4 dimethyl 3-pentanol is which type of alcohol? Pentanol in the sense, first you write down the carbon chain. Just wait. Yeah. First you write down the carbon chain. How many carbons are there? 5 carbons. That too at which position? Pentanol. Third position, ol, alcohol. At second position as well as at fourth position we have two methyl groups. Yes or no? So this I can write it as CH3. Fine. CH, CH, CH. So our alcohol group is connected to a carbon. That carbon is connected to two carbons. So that carbon is secondary carbon. So hence our alcohol is secondary alcohol. So option B is the correct answer. Okay. If you know the answers, you can post it in the live chat, right? That will be better if you know the answers. But I'll discuss it. Okay. Glycerol contains. Glycerol contains. Glycerol is an example of trihydric alcohol. Glycerol is an example of trihydric alcohol consisting of how many OH groups? 3 OH groups. Structure, if you observe it, it is a structure of glycerol can be given, and it is primary alcoholic group, it is secondary alcoholic group, it is also primary alcoholic group. So how many primary alcohol groups are there? 2 primary alcoholic groups are there and 1 secondary alcoholic group is there. Accordingly you can pick out the answer. So answer 2 is the correct answer, or option B is the correct answer. 1 secondary and 2 primary alcoholic groups. Okay. The IUPAC name of sec-butyl alcohol. The IUPAC name of sec-butyl alcohol. Sec stands for secondary. Secondary butyl alcohol means this carbon is connected to two carbons, hence it is named as secondary carbon. OH group is attached to this carbon, hence it is secondary. There are 4 carbons, so it is secondary butyl alcohol. So 2-butanol, 1, 2, 3, 4. 2-butanol is an example of secondary butyl alcohol. Okay, so option B is the correct answer for it. Hope it is clear for you, right? You can say the answer if you know the answer. If you feel it is correct, if it is wrong also, not an issue. Post it in the live chat. Meanwhile, I'll be discussing. We will try to approach towards the answer. Okay. The IUPAC name of So here alcohol and here double bond. So started from the left side, numbering 1, 2, 3, 4, 5. 5 carbon chain. It is a 5 carbon chain. So almost, if it is a 5 carbon chain, in the sense almost these options are vanished. Only one option can be sustained. Okay. So third position alcohol. First position we have ene, right? So I can say total 5 carbons. So pent 1n 3O. Cut off E, of course. Pent 1n 3O. Understood? It is pent 1n 3O. So option 3 is the correct answer. Option 3 is the correct answer for it. Now, total number of structural isomeric alcohols. Total number of structural isomeric alcohols with formula C4H10O. So we have to write down the isomers of alcohols, that to structural isomeric alcohols only. So we will be taking only chain isomers here as per the options if you observe it, whose molecular formula is C4H10O. So possibilities if you observe it, there are 4 carbons. It is N-butanol. It is N-butanol, right? So another one also you can take it. So chain length of the carbon has been decreased. So we have created a branch here. So it is 2-methyl propanol. 2-methyl propanol, and it is butan 2-ol. It is butan 1-ol, of course. That is butan 1-ol, but it is butan 2-ol. And it is third butyl alcohol, as you know. It is a tertiary alcohol, third butyl alcohol. So like that, how many structural isomers are possible? 4 structural isomers are possible for molecular formula, for alcohol of molecular formula C4H10O. Understood? All are having same molecular formula, but chain length is different. Here 4 carbon chain length, here 3 carbon chain length, here 4 carbon chain length, but there is a change in position. Okay, there is a change in position of the alcoholic functional group. It is butan 1-ol, it is butan 2-ol. And here chain length, if you observe it, here also 3 carbon chain length is there. Okay, here also 3 carbon chain length is there. And so there itself OH group is attached to the second position carbon. Second position carbon, that is an example of a tertiary alcohol. Okay, so it is third butyl alcohol. Total 4 structural isomers are possible. Simply you can use the formula also. Number of isomers formula 2 raised to n minus 2 C4H10O. This is the molecular formula given. N is the number of carbon atoms. 4 minus 2, that is 2 square, which gives you 4. Okay. So then it can be taken as an answer D, I think so. It is in the option. So to 4 it is there in the option D. But suppose if stereoisomer is considered, then total number of alcohols will be 5. But we are not considering stereoisomers here. Okay. Another important question we have, that is Grignard reagent based question. The reaction of CH3MgI, methyl magnesium iodide with acetone and hydrolysis of the resulting product gives. Acetone, what is the formula? CH3, C double bond O, CH3 treated with CH3MgI. It is minus MgI plus. I can polarize the bond in this way. So CH3, C, CH3. O is being attracted by positively charged magnesium iodide, and this carbon is being attracted by CH3. And they said followed by hydrolysis. If you do the hydrolysis, as you know, you have to break this bond. Here H, here OH. So MgOHI can be removed. Then it forms CH3, C, CH3, OH, CH3. Our OH is attached to that carbon having 3 carbons, hence it is tertiary alcohol. Hence it is tertiary alcohol. Understood? So option D can be given, that is CH3 thrice COH. CH3 thrice COH. Hope it is clear for you, that you can see it very clearly, right? CH3 thrice COH, how we got it. Acetone always gives secondary alcohol, sorry, tertiary alcohol. Aldehyde gives secondary alcohol, except formaldehyde. Formaldehyde gives primary alcohol. These reactions we are discussed under preparation of alcohols. Before solving questions, you have to revise the theory. Once if you revise the theory, it will be very easy when I am explaining it, or else definitely you will face difficulty. Let's see the next question. We have, there is an assertion reasoning question. There is an assertion reasoning question. So here in the fermentation process of molasses, in the fermentation process of molasses, along with yeast, NH4 twice SO4, NH4 thrice PO4 is added, and reason is ammonium phosphate and ammonium sulfate act as a food and helps in growth of yeast. Generally, ethyl alcohol can be manufactured. Ethyl alcohol can be manufactured by fermentation process. By which process? Fermentation process. Fermentation is nothing but breakdown of complex molecules. Breakdown of complex molecules into simple molecules. In the presence of microorganisms. In the presence of microorganisms such as yeast. So ethyl alcohol can be commercially manufactured by a process called as fermentation. Fermentation is nothing but if you take a larger molecule or a complex molecule, it can be, it can be break down into simpler molecules. A simple molecules in the presence of microorganisms such as yeast. That phenomenon or a process is known as fermentation. So fermentation we can do it for molasses. So we will do fermentation for molasses. Molasses is a thick black colored liquid which is obtained as a byproduct in the manufacture of sugar from cane sugar in the sugar industry. So while we are manufacturing the sugar from cane sugar, right? So we will get a thick black colored liquid which is consisting of around 50% of sucrose. And that sucrose must be diluted with water to make 10% of the sucrose. Clear? So once we have diluted the sucrose, actually the sucrose in the sense it is nothing but molasses, of course, sorry. It is nothing but molasses which is consisting of 50% of sucrose. And we are making it this way. We are making this molasses as consisting of 10% of sucrose by diluting with water. So initially our molasses is consisting of 50% of sucrose, and now that molasses is transferred to vats. VAT is nothing but, okay, doesn't mean value added tax. VAT is nothing but a fermentation tubs, a big tubs, right, a big tubular tubs in which, into which we are transferring this molasses, and after transferring the molasses, what will happen? We will be adding the ammonium sulfate. As well as we will be adding ammonium phosphate, and to which we are adding yeast cells. Yeast cells are adding to the vats. And why we are adding these two salts here? Why? Because yeast has to survive in that molasses. To survive in the molasses, we need to provide the food supplement. That food supplement is ammonium sulfate and ammonium phosphate. So ammonium sulfate and ammonium phosphate can be added to the fermentation vat, which those are can be used as a food supplement for the yeast cells. Those are used as a food supplement for the yeast cells. So what will happen? So we will maintain a temperature around 30 to 35 degrees Celsius, room temperature. So we will leave that yeast cells in the vats for almost 2 to 3 days. It can do all the processes in that vat itself. Okay, 1, 2, everything, right? It can sustain its life, right? So it can live its life in the fermentation vat for 2 to 3 days. After 2 to 3 days, what will happen? Yeast cells can be expired, and yeast cells will be expired, and they produces yeast cells will expire, and they produces two enzymes. One is invertase and another one is JEEMAINS. One is invertase and another one is JEEMAINS. Understood the point, children? They produce two enzymes. One is invertase and another one is JEEMAINS they will produce. And these two enzymes, children, those two enzymes degrades our complex substances into simple substances. Complex substances into simple substances. So what will happen here? We have sucrose. No, molasses is consisting of sucrose. That sucrose undergo hydrolysis as we have added water in the presence of which enzyme? Invertase. So sucrose can be break down into two substances. One is glucose and another one is fructose. Both are having same molecular formula. Both are having same molecular formula. So invertase can break the sucrose molecule into glucose and fructose. Sucrose is the complex substance. Sucrose is the complex substance. Glucose and fructose are simple substances, right? Still, either glucose or fructose can be furtherly break down into ethyl alcohol in the presence of which enzyme? JEEMAINS enzyme. In the presence of JEEMAINS enzyme. Okay, so it produces the carbon dioxide, and it releases the carbon dioxide as well as C2H5OH can be produced. So this is ethanol or ethyl alcohol, and that ethyl alcohol, whatever we got it, which we will get it around 10 to 15% of ethyl alcohol through this process. And this 10 to 15% of ethanol is technically called as wash. It is technically called as wash, and we need to subject this wash to fractional distillation. Subject it to fractional distillation for the removal of water, and you will get around 96% of alcohol, and that 96% of alcohol is called as rectified spirit. 96% of alcohol is called as a rectified spirit. So here for the fractional distillation process, we need large amount of water. That is the reason most of the alcohol industries are established nearby the river or nearby the water sources. Wherever water sources are maximum, these alcohol industries can be established for the requirement of the fractional distillation. And we got 96% of alcohol, but still we have 4% of water. That water also can be removed by adding CaO. This CaO is called as quicklime, and the 96% alcohol can be converted into 100% alcohol. This is called absolute alcohol. This is called as a absolute alcohol. Understood the point? See, I have not discussed about commercial methods of the ethanol. Just I gave a brief idea in previous lectures if you observe. That's why I am explaining in detail here about the fermentation process. Understood? So 100% alcohol is called absolute alcohol. So we have prepared absolute alcohol. So obviously there is a possibility of misusing this alcohol, right? So people might drink it even. Why? Because it is available at the cheaper cost. So to avoid that misuse, what they will add? They will add pyridine and copper sulfate. They will add pyridine and copper sulfate. They will add pyridine and copper sulfate. Then that alcohol is called denatured spirit. That alcohol is called denatured spirit. It is not suitable for the drinking purposes. By mistake, if anyone drinks denatured spirit, it causes blindness. Sometimes it may lead to even death. Sometimes it may lead to even death. They have to kick the bucket, no more doubt in it, right? So denatured spirit is not suitable for the drinking. It is suitable for the commercial purposes. Understood? So take a screenshot of it. Pause and take a screenshot of it. That's better. It will give a clear idea about how ethyl alcohol can be manufactured industrially. Understood the point? I'm erasing it. Right? So let's see the question. Now you can answer this question easily. In the fermentation process, we will add ammonium sulfate and ammonium phosphate. They can act as a food and helps in the growth of yeast. So both assertion and reason are correct. R is the correct explanation of A. Understood? Next question. The boiling point of ethanol is less than that of water, though the molecular weight of ethanol is more than that of water. Though the molecular weight of ethanol is more than that of water. And reason, ethanol molecules are not highly associated through hydrogen bonding as in water. In water, oxygen is attached to hydrogens only, but in ethanol, oxygen is attached to hydrophobic part. So, which which makes the alcohol molecule to less hydrogen bonded. Okay, that's compared to water. That's the reason. So that's why ethanol molecules are not highly associated. So obviously boiling point of ethanol is less than that of water, right? So that is because of both A and R are true, and R is the correct explanation of A. Another important question, you can answer it by the hint itself. Two organic compounds A and B react with sodium metal and release hydrogen gas. Both they react with the sodium metal separately and give hydrogen gas. A and B react with each other to give ethyl acetate. The A and B are. Ethyl acetate is nothing but ester. Ester can be formed by reaction of alcohol and carboxylic acid. Alcohol and carboxylic acid. But they mentioned very clearly ethyl acetate means CH3COO C2H5. So that combination must be CH3COOH and C2H5OH. Okay. They gave the reactions also. Ethanol reacts with sodium metal, gives hydrogen gas. Similarly, carboxylic acid also reacts with sodium, it liberates hydrogen gas. So both they react with each other in the presence of an acid. It forms ethyl acetate. This reaction is called as esterification. Alcohol beverages contains alcohol beverages such as beer, okay, wine, whiskey, rum, gin, brandy. All those are alcohol beverages only, which consisting of ethyl alcohol. That is ethanol, right? 11. Another important question we have N-propyl alcohol. N-propyl alcohol as well as isopropyl alcohol. N-propyl alcohol means CH3, CH2, CH2OH. This is N-propyl alcohol. Isopropyl alcohol CH3, CHOH, CH3. It is 1 and it is 2. Both they can be distinguished by. If you observe it, N-propanol or propyl alcohol is primary alcohol, whereas this alcohol is secondary alcohol. This alcohol is secondary alcohol. Both primary alcohol and secondary alcohol can be distinguished by, as you know, Lucas reagent. That's the best test. As well as you can check it oxidation with PCC. That is Collins reagent. Pyridinium chlorochromate PCC. It is called as Collins reagent. So oxidation with PCC. Primary alcohol gives aldehyde. Primary alcohol gives aldehyde, secondary alcohol gives ketone. Oxidation gives, in oxidation test also distinguishes the primary as well as a secondary. Primary as well as a secondary. Hope you understand. So let's see the correct answer here. As you know, yeah. Secondary alcohol does not give the yellow PPT in a iodoform test. Secondary alcohol does not give the PPT in iodoform test, but primary alcohol can give. Primary alcohol can give. So primary alcohol does not give PPT with Lucas reagent. Secondary alcohol reacts slowly, and primary alcohol on oxidation gives aldehyde. Secondary alcohol gives ketone, right? So with same number of carbon atoms, but acid with less number of carbon atoms. But acid cannot be formed with PCC. You don't worry about it. Why? Because PCC is a mild oxidizing agent. Okay, so you can say that you know. So there itself, which test? Lucas test. Next, oxidation with PCC. Another test what we have? Iodoform test. Iodoform test. Understood? Iodoform test. So here secondary alcohol does not give the yellow PPT in iodoform test. So iodoform also can give the distinguishing test between primary and secondary alcohol. Understood? So option A first is the correct answer. ABC. ABC is the, all ABC will give the statements over there. If you check it, ABC statements are correct. The reaction of ethanol. Ethanol means C2H5OH. With H2SO4, two conditions are there. Concentrated H2SO4. At 140 degrees Celsius, it gives diethyl ether. Whereas at 170 degrees Celsius, it gives ethylene or ethylene, as well as that C2H5OH as a first step whenever it is treated with H2SO4, it forms C2H5OSO3H, that is ethyl hydrogen sulfate. Alkyl hydrogen sulfate also can be formed, but not acetylene. It cannot form acetylene. So option 3 is the correct answer for it. All we can get it. Okay. Yeah, it is Grove's process. ROH plus HX giving rise to RX plus H2. H and OH combined, right? Treating with HX in the presence of anhydrous ZnCl2 called Grove's process. Reactivity can be given as tertiary greater than, secondary greater than primary, that you know. Why? Because proceeds through the formation of carbocation intermediate. Yeah. The reaction ROH plus HCl reversible with RCl plus H2. So far the completion of the reaction we use along with the reactants. So which one we can use along with this reactants? So to make it reversible, we have to use concentrated sulfuric acid. Why? Because concentrated sulfuric acid can remove the water. Okay, which can be completely displaced by halogen group. Halogen group can be completely displaced by OH. That displacement reaction is nothing but substitution, nucleophilic substitution reaction. Remaining are not nucleophiles. OH is a nucleophile, so that's why it is easily displaces the, it can easily displaces the halogen. An organic compound dissolved in benzene and evolved hydrogen with sodium. So obviously with sodium it is evolving or releasing the hydrogen, in the sense that compound is alcohol. Just now we have seen reactions in previous questions also. C2H5OH plus Na giving rise to C2H5ONa and liberates hydrogen gas. Clear? Regarding ethyl alcohol, the wrong statement is, children, it is neutral to litmus, of course, because it is almost weak acid. It gives yellow crystalline PPT with I2 plus dilute NaOH. Whenever you see I2 plus NaOH, in the sense, it is the reagent for the iodoform test. It is the reagent for the iodoform test. Is it clear for you? That is the reagent for the iodoform testing. So alcohol can give the yellow crystalline PPT, that is the characteristic PPT or characteristic precipitate in iodoform test. So generally if any compound which exhibit iodoform test, that has to give the yellow crystalline PPT. So alcohol can give the yellow crystalline PPT with iodoform reagent. It gives a product of fruity order on reaction with CH3COOH. C2H5OH plus CH3COOH. Ethyl alcohol reacts with carboxylic acid. It forms ethyl acetate, and ethyl acetate smell is apple smell. It gives a fruity smell. Generally esters are fruity smelling compounds, right? So that is also correct. It gives turbidity spontaneously on the addition of Lucas reagent. If you observe it, ethyl alcohol is an example of a primary alcohol. Generally primary alcohol cannot give the Lucas test easily, right? Until and unless if you heat it, not this heating, you have to heat it. Okay, so until and unless if you heat it, it cannot give the Lucas test. So they gave it gives turbidity spontaneously. Spontaneously turbidity can be given by tertiary alcohols but not by primary alcohols. So option 4 is the correct answer for us. Primary and secondary tertiary alcohols may be distinguished from one another by, as you know that reactions, one is Lucas, another one is oxidation methods. Action of hot HI is with ethers, not for the alcohols. Another important CET question we have discussed even in the our regular classes also, right? C2H4 plus HCl in the presence of AlCl3, A gives you C2H5Cl. Aqueous KOH means substitution, C2H5OH. 140 degrees Celsius means it forms diethyl ether. Intermolecular dehydration takes place. So option 2 is the correct answer for us. Next question. Similar, almost similar, but the thing is here 170 degrees Celsius, CH2 double bond CH2. It will give ethene or ethylene, but not diethyl ether. So this time it is option A, not diethyl ether. Diethyl ether means 140 degrees Celsius should be used. Next, ethanol treated with some X at 350 degrees Celsius gives ethene. What is X? They mentioned very clearly 350 degrees Celsius. 350 degrees Celsius is possible for alumina. Possible for alumina. Alumina formula is Al2O3. Alumina also can act as a dehydrating agent. Next we have the product formed when C2H5OH is heated to 250 or 260 degrees Celsius in the presence of Al2O3. Observe it, whenever if you use Al2O3 at 350 degrees Celsius, then it will give ethene or ethylene. But at 250 to 260 degrees Celsius, it gives ethene or ethylene. Understood? It is also another distinguishing test among primary, secondary and tertiary alcohols. When alcohol treated with copper at 300 degrees Celsius or 573 Kelvin, it gives acetaldehyde, CH3CHO. It gives acetaldehyde, that is CH3CHO. So this reaction is dehydrogenation. Removal of hydrogen takes place. That's why above reaction is an example of dehydrogenation reaction. Did you understand? So they gave a reaction C2H5Cl plus KOH alcoholic, means in the KOH is dissolved in alcohol, in the sense alcoholic KOH is an example of elimination reagent. It's a elimination reagent. Its action is elimination, means dehydrohalogenation. It gives organic compound A. That organic compound reacts with HCl, right, with the help of B, a reagent in the presence of a catalyst, gives C. Identify A, B, C. First of all, A, if you know, C2H5Cl plus alcoholic KOH means C2H4, elimination, ethene you will get it. So you can omit the first option, and that A react with HCl. In the presence of anhydrous AlCl3, it will give C2H5Cl. So option, those reactions they have given it clearly if you observe it. C2H4 HCl AlCl. Okay, anhydrous AlCl3 gives you C2H5Cl. This is A, it is B, it is C. That you can get it in option 3. So option 3 is the correct answer for us. Okay. Next, C2H5OH acidified K2Cr2O7. Initially it gives aldehyde. On further oxidation it gives carboxylic acid. Understood? C2H5OH, why it gives aldehyde? It is a primary alcohol. Generally with primary alcohol, if they undergo oxidation, they produces aldehyde, and further oxidation gives you carboxylic acid. Okay, so answer is acetaldehyde and acetic acid. So A is CH3CHO. Here you will get acetic acid CH3COOH. Understood? If it is not clear, I am writing here. Observe it. Hope it is clear for you. Right. Next, a compound X on reaction with I2. On reaction with I2 in the presence of NaOH. Whenever I say I2 in the presence of NaOH, then definitely you have to understand that it is iodoform test. It is a iodoform test. So generally alcohols which are having CH3CHOH group, alcohols which are having CH3CHOH group in it can give the positive iodoform test. Can give the positive iodoform test. If you keep H here, that is ethyl alcohol. So ethyl alcohol can give the positive iodoform test. Hydrogen bonding is maximum in ethanol formula C2H5OH, diethyl ether C2H5O C2H5, ethyl chloride C2H5Cl, triethylamine, that is C2H5 thrice N. So here hydrogen bonding, though it is possible, but because of bulky alkyl groups less. And compared to all of these, here it cannot, C2H5Cl cannot form, ether can form, but here also 2 ethyl groups are there. So compared to remaining these 3, ethanol can form hydrogen bonding, which is maximum. Maximum association takes place in, ethanol because of OH. Moreover, in another way you can say oxygen is most electronegative, right, compared to nitrogen. Next, 23 mg of sodium metal is placed in excess of alcohol. Which alcohol can produce more amount of H2 gas? Generally, alcohol whenever react with sodium metal, it produces the H2 gas. All they can react in the similar manner, right? All they can react in similar manner. Why? Because we are taking 1 mole only, right? That is the reason. So 1 mole it gives that half H2. Generally 1 H2 if it gives 22.4 liter, half H2 means 11.2 liter. Next, 3 moles of ethanol reacts with 1 mole of phosphorus tribromide PBr3, forms 3 moles of bromoethane and 1 mole of X. That X will be obviously phosphorus acid. So option 4 is the correct answer. Instead of that X, we can write H3PO3. Clear? Sometimes they give you reaction like this also. Br2 plus red phosphorus. Bromine in the presence of red phosphorus, that is PBr3. So it gives you phosphorus acid. Did you understand? Which of the following compounds gives hello PPT on eating with alkaline solution of iodine? Alkaline solution of iodine in the sense, obviously I2 plus NaOH. I2 plus NaOH, which can give, as I told you already, which is consisting of CH3CHOH group, can respond to the iodoform test, right? So they gave alcohols having alpha methyl groups, gives the yellow PPT in iodoform test. Alcohols which are having alpha methyl groups give the yellow PPT in iodoform. So all these are correct. Simply you can say that which is consisting of CHOH. Alpha position, it is alpha, which is at alpha is having methyl group. If that alpha is having methyl group, then it is giving iodoform test. All these are having that CH3CHOH group. So B, C, D is the correct answer. Another simple reaction. What are X and Y in this reaction? C2H4 plus H2SO4 at 80 degrees Celsius. Initially it gives the alkyl hydrogen sulfate. Upon hydrolysis it gives the alcohol. That you can see here. Ethene plus H2SO4. It gives C2H5HSO4, and which is upon hydrolysis gives ethanol plus H2SO4. So here X is the ethyl hydrogen sulfate and Y is the alcohol, that is ethanol. C2H5OH4 and C2H5OH. Understood? Some assertion reasoning questions are given. Observe it carefully. Assertion reasoning questions generally are important for NEET and JEE mains. Ethanol is miscible in all proportions with water. Ethanol is completely miscible with water because of the hydrogen bonding formation only. So what I can say here, both A and R are true, and R is the correct explanation of A. That you can check it here. Hydrogen bond is formed between water and alcohol molecules. Because of the formation of this hydrogen bond, ethanol is miscible in all proportions with water. Hope you understand. Yeah. CaCl2 is also an example of a desiccating agent or a drying agent. Can't be used for drying ethyl alcohol. It can't be used for drying ethyl alcohol. Calcium chloride can form an addition compound with ethyl alcohol. That's the reason only, right? Because of that reason, it cannot be used as a dehydrating agent or a drying agent for ethyl alcohol, because it forms an addition compound with ethyl alcohol. Okay, so both A and R are true, and R is the correct explanation to A. Next, if you observe it, ethyl alcohol is soluble in organic solvents. It is one of the advantages for ethyl alcohol. It can be soluble in, polar solvents as well as non-polar solvents. It can be soluble in polar solvents like water due to the formation of hydrogen bonding, and it can be soluble in non-polar solvents due to the non-polar group. Non-polar carbon part is there, a hydrophobic part is there. It can be soluble in organic solvents. So ethyl alcohol is having non-polar ethyl group. That's the reason. So both A and R are correct. Assertion and reason are correct, and R is the correct explanation to A. Okay. Alcohols on dehydration can produce ether as well as alkene, that under different conditions. As you know, at 140 degrees Celsius it produces ether. At 170 degrees Celsius it produces alkene. Means if you change the temperature, products also changing. Dehydration of alcohol proceeds to the formation of carbonium ion. Intermediate is a carbonium, right? So that because of the formation of carbocation and followed by temperature conditions also, which makes the formation of two different products at two different conditions. Okay, so first one is a correct assertion. So it might be the last question. When ethyl alcohol reacts with bromine in the presence of red phosphorus, just now we have discussed, Br2 plus red phosphorus, in essence it forms ethyl bromide or bromoethane. Ethyl bromide or bromoethane. Understood? Yeah. So these are the questions from level 2 from alcohol chapter, right? So still we have phenols and ethers also. We will discuss those questions also, right? Hope you like the video. So if you like it, please click on the like button. If you haven't subscribed to my channel, please subscribe and click on the bell icon for notifications and videos. If you have any doubts, don't hesitate to ask. Please post it in the comment box. During the session, post it in the live chat. Understood? Children, once theory is completed, please revise the NCERT for better understanding. And whenever I am discussing the questions, it would be easier to you to understand if you revised it already. Okay? Hope it is clear. These are the questions we have solved based on alcohols. Still, we have few more questions we will be solving in forthcoming sessions. Until then, take care. Bye bye. Signing off.